Hello sir, this is Muhammad Yasin Dawlat, studying MSc final year, Sri Krishna Devaraya University. Today I would like to say about quarks model, that is in the nuclear physics, related to nuclear physics. Into the discussion. Ordinary matter and all the stuff that makes of world is made up of atoms, and the atoms are made up of electrons, protons and neutrons. We know that the electrons are elementary particles. Electrons are elementary particles that are not made up of further fundamental particles. But neutrons and protons are not elementary particles. They are made up of further fundamental entities which are known as quarks. So these quarks are the fundamental entities that make up class of particles known as hadrons, of which the neutrons and the protons are part of. To understand about the quarks, we have to know about the eightfold way in which is an organizational scheme or grouping together different kinds of hadrons particles. These hadrons are the class of particles that experience the strong interaction. Now there is a huge diversity of hadron particles out there, and the very natural questions that comes to mind is, are all the particles are elementary, or they are made up of any further elementary particles? This question led to an idea of eightfold way, which was basically arranging these hadron particles into a groups or a geometrical pattern based on same spin but different charge and different strangeness. For an example, let us consider baryon octet. In baryon octet, the elementary particles are arranged in a geometrical fashion in this way, and these elementary particles consist of quarks that are made up of quarks as down quark, up quark and down quarks, two up quarks, down quark, two down quarks, strange, one up quark, one down quark, and strange, up quark, strange, down quark, strange, up quark, and strange. These are the eight lightest baryon particles having the spin that is equals to half, having the different strangeness and different charges. All these particles, elementary particles, are having the spin of 1/2 with different strangeness and different charges. As we know, the hadrons are the subatomic particles that experiences strong interaction, but hadrons are subdivided into two groups. Hadrons divided into two groups. Those are bosons and fermions. These have integral spins and not allow exclusion principle, whereas these fermions will allow and follow follow exclusion principle. Similarly, 9 muon particles can be arranged. 9 muon particles can be arranged and they all have the spin equals to 0. Spin equals to 0 but different strangeness and different charge. And these kaon particles, pion particles, neutrinos, kaon particles, antikaon are having the strangeness equals to +1. These pions having strangeness equals to 0 and this having the strangeness equals to -1 and charge that is equals to -1 and all these kaons and these neutrinos and pion having the charge equals to 0 and the kaon and pion is having the charge equals to +1. Similarly, in the baryon octet also having the strangeness equals to 0, -1, -2 and the charges equals to -1, 0 and +1. These elementary particles further forms the another kind of the geometrical structure that is known as baryon decoupler, and these are having the strangeness such as 0, -1, -2 and -3 and these charges are ranging from -1, 0, +1 and +2. And these elementary particles are made up of quarks, 2 down quarks, 3 down quarks, down quark, up quark, down quark, 3 up quarks, 2 down quarks and strange, 2 up quarks, 1 up quark, 1 down quark and strange, 2 up quarks and strange, 2 strange down quark, 2 strange up quark, 3 strange quarks. These elementary particles in the baryon decoupler having the spin that is equals to 3/2 and different strangeness, different charges. Now all these fundamental particles making the geometrical structures make up a new question that all these particles are made up of something more fundamental or they are fundamental on their own. Let us consider a periodic table in which more than 100 elements that are eventually made up of electrons, protons and neutrons are in different combinations, as there are in the same way the atoms create the huge diversity. These elementary particles create the huge diversity in the atoms that can be created by recombination of the electron, proton, neutron in different combinations. In those, hadron particles are generated by recombining of certain fundamental entity that lead to an idea of quark model.